Algebra 2, Chapter 1, Section 1, 2, Part 2. So we're going to get started with our example 3, and we're going to look at additive and multiplicative inverses. So we know that our properties, we talked about properties in the last video. Inverses, the additive inverse is what we call it, would be the opposite of a number. And the multiplicative inverse, we would call the reciprocal of a number. So A, and the reciprocal of A is 1 over A. Instead of like A being A over 1, when we flip it, we take the reciprocal, and that's 1 over A. So let's see if we can figure out what the additive inverse and multiplicative inverse for each of these are. And so when I look at this number here, in order to take the additive inverse, that's pretty easy. I'm going to put additive inverse here. So you know what I'm talking about. The additive inverse is really just to change the sign. So instead of a negative 1 and 3/4, I'm going to write a positive 1 and 3/4. And honestly, the plus sign was unnecessary, but plus 1 over 3, plus 1/3, 1 and 3/4 would have been good enough. But the multiplicative inverse, I used a word there just a few moments ago that I didn't use in the first video, but really the multiplicative inverse means to take the reciprocal. In order for me to take the reciprocal, I got to write this thing as a fraction. So the fraction here would be, I'm going to write it as an improper fraction because this is a mixed number and that's not going to work for me to take the reciprocal. So 1 times 4 is 4 plus 3 more gives me 7. So 7/4, this is a negative 7/4. The multiplicative inverse would be to take the reciprocal of it. It stays negative. We don't change the sign, but we flip it. The numerator and denominator go topsy-turvy, and this is the multiplicative inverse. Let's try this one over here. Additive inverse is pretty awesome. All I'm doing is changing the sign. So since this is positive, I'm going to rock a negative 1.25 and I'm done. That's it. Additive inverse. Remember, all I got to do is kind of make it like its evil twin. And when I add it together, I get 0. But the multiplicative inverse is a little bit more involved because I need to first make sure I can write my number as a fraction. So this number here, 1.25, written as a fraction, first of all, or at least a mixed number, is 1 and 1/4. Then when I write that as an improper fraction, it's 1 times 4 plus 1 more gives me 5 over 4. So now, starting with 5/4, if I were to write the multiplicative inverse, which we know to be the reciprocal, I'm just flipping this thing. 4 over 5. So my answer, I'm going to box out my answers so you know which ones are right, would be here. All right. So my answer to the additive inverse is merely changing the sign. My answer to the multiplicative inverse means to change it to a fraction, improper fraction, and flip it. All right. Let's take a look at this example here. We've got a little bit of a word problem. It says a restaurant adds a 20% tip to the bills of parties of 6 or more people. Suppose the server waits on 5 such tables. The bill, without the tip for each party, is listed in the table. How much did the server make in tips during the shift? So we see that this server is going to make about 20%. Well, we'll make 20% because the restaurant itself will add the 20% right on, since they had large guests at the party, large guests at the tables. And so this particular server had 5 different large guests, or large parties of people, and this is the amount of money that the bills came up to. How can we calculate 20%? Well, the beauty of this and how this really relates to the distributive property is, certainly I can go through and consider 20% of this guy, and then 20% of this guy, and then 20% of this guy. You guys get where I'm going with this, right? I can do that. That makes sense. However, the reality is the fact that all of them are going to have a 20% a tip added to the final price. What we would do is really, we can just add it all up, right? I can take each of these and add them up, add all of these up, right? So I'm taking all of the bills that were charged to each of these different parties, and then I'm going to calculate 20% of the sum, right? And we remember, when we calculate 20%, we multiply by the decimal version of 20% and we get our answer. So the quick and dirty way to do this, so why is this the distributive property? Well, I literally could, as we mentioned before, take each one and figure out what 20% of each is, and then add all of that up and say that that's the amount of cash that this server got. But I'm not going to do that. I'm not going to do that just yet. What I'd rather do is do it the more sophisticated and easy way because I know that they're both equivalent, right? So let's go ahead and do it. So if I take this and I sum all of these costs up for all of these parties, I would get $1,093.50. And I'm going to multiply that by zero point 0.2. That zero point 0.2 is going to tell me exactly what the tip amount was. And we end up with a grand total of $218.70. Our final example for this lesson will be example 5. We're going to simplify an expression. And so simplifying really means, and this is something that we should remember from Algebra 1, but simplifying really means we are joining like terms together and we are getting rid of parentheses when we can. And the way we get rid of parentheses in this case is that we're going to use the distributive property. And so right here, I'm going to multiply 2 times 5m and 2 times n. And what that's going to do is that's going to break the parentheses off. So 2 times 5m is going to be 10m, and 2 times n is going to be 2n. Over here, I'm going to distribute the 3 and over the 2m and the minus 4n. And what I end up with is 6m minus 8n. Oh, just lied to you, and I'm glad you caught me in my lie. My bad. It's going to be 3 times 2 is 6, but 3 times negative 4 will give me a negative 12. So I'll get negative 12n. Let me get my pen back. Negative 12n. Thank you for your patience. And so now what we're left with is this thing, right? Where we've got these different terms. And if you remember from Algebra 1, we're going to join like terms together. Here, this is an M term, and this is an M term. Those guys are kind of like family. And this is an N term, and this is an N term. Notice they have the same exact, when we call them family, or we say that they can be joined together, they're like terms, it's because they have the same exact, um, variables next to it. And so what we're going to do is we're going to take our 10m and our 6m, join those guys together. If I've got a positive 10 and a positive 6m, I've got 16m. And if I have a positive 2m but a negative 12n, I'm adding two numbers with different signs. I subtract and take the sign of the higher, and I get 10n. All right, so that is our final problem. I hope that made sense. Please feel free to ask me any questions if you have them. Your assignment will be found on pages 15 and 16 and 18. And I'm going to ask you to do 19 through 35. Looks like a lot, but you're just kind of describing what's going on. You're not actually doing any work in those. 43 to 62, you're doing a little bit more work. And 74 to 77 is a bit thinking. You're thinking a little bit deeply about some mathematics. And I think it'll make good sense to you. Let me see if I can pull it up so we can take a glance at it. So you're going to, that's my family. Let's see if we can pull up the assignment. We'll go and we're looking at doing all of these. If you notice these problems from 19 to like 35, all you're doing is telling us what property down here is illustrated, and over here you're telling me all about what kind of number we have, like we did in the first example. And then we go on to talk about the additive and multiplicative inverses, something we did in example 3, I believe. And then we're simplifying, which is really a necessary skill to develop here up to number 58. And then when we scroll down here and we're skipping that page and we're going all the way over to page 18, we're looking at this kind of an extended lesson. So this is a little bit of deeper thinking. It's getting your brain thinking about deeper mathematics, and I want you to try hard. Feel free, if you ever want to work on some of the maintaining your skills and the prerequisites for the next section. I'm not assigning it in this lesson, but it's something that is always good to kind of work on and make sure you're keeping your mental mathematical pencils sharpened. I definitely hope you have a good day, and I look forward to talking to you soon about any questions or problems you have. Please take good care. Bye-bye.